Good evening, sir. My name is Jeremy. I'm gonna do the question number 1, potentiometer. Okay. Electromotive 2 over electromotive 1 is equal to AJ, balance line of AJ, in AB over AB, and electromotive 2 is equal to electromotive 1 multiplied by AJ over A. Okay, this is the answer.
Hi guys, I'm Heng Yuan. Now I will be doing the question 2 of the potentiometer exercise. Okay, now let's start. For this question, we are required to find the E2. When we find the E2, the R is negligible because the secondary has no current. Why it doesn't have a current? Because it doesn't have a loop. So from this circuit, we know that E1 is directly proportional to AB. E2 is directly proportional to AJ. So to find the E2, we need to combine these two equations. Okay, so you'll get something like this. Then we make E2 as the subject, and then we will get AJ over AB times E1. That's it.
Hi, I'm Be. I'm going to explain the question on exercise 3. So this is the circuit and we are going to find E2. We all know that E1 is directly proportional to AB, and VAJ, potential difference of VAJ is directly proportional to AJ. So we can make the first equation, which is E1 over VAJ equal to AB divided by AJ. So here's the first equation, and the second equation, we need VAJ, and we use the potential divider equation to make this equation. So VAJ is here, and how to find potential difference of X, Y. So is R2 divided by total resistance, which is R plus R1 plus R2, then times with E2. So finally we have Vxy equal to VAJ, XY and AJ. Potential difference is the same, and we put in our equation, first equation and second equation, and then here's the final result. Okay, thank you.
I'm Wilson from Science 2. Hello, good day. Today I would like to discuss about this question, question number 4 from the set of questions that Mr. Salfi gave. Okay, so we need to find value of E2 in terms of AB, AJ, the resistor value R3, and E1. So for this question, we need to assume that the galvanometer has no deflection and the internal resistance R is ignored. So how do we find E2? First we need to know the value of VAB, the potential difference AB over the E1 is directly proportional to the ratio of the resistance of the wire AB over the total resistance and R3. Since the internal resistance is not really that, so we throw the E1 to the other side. We get E1 AB over RAB plus R3. So this is the value of VAB. Then after that, we need to find VAJ. So VAJ over this here over VAB is directly proportional to it is directly proportional to the length. So the length of A to B is AB over, oh sorry, that's wrong, it's AJ right here, of AJ over AB. So we throw the VAB to the other side, we get AJ over AB times VAB. So we just insert this in here, we get my ruler, AJ over AB E1 RAB over the resistance RAB plus R3. So this is how you find the answer for E2. That will be all.
Good afternoon to my teacher and my fellow friends. Today, I would like to present my solution for the questions 5 in the exercise potentiometer. This is the potentiometer given by the question. And the question tells us to find the EMF of the second battery labeled as E2. For your information, at balance point, the potential difference between point A and point J is equal to the potential difference between point S and point Y. By using the equation V equal to IR and R equal to resistivity times length of the wire divided by cross-sectional area of the wire, we can deduce that the potential difference is directly proportional to the length of the wire. Hence, the potential difference between point A and point B is directly proportional to the length of the wire from point A to point B. And we have found out that potential difference between point A and point B is equal to the EMF of the first battery labeled as E1 times the resistance of the wire from point A to point B labeled as RAB divided by the total resistance in the circuit, that is R3 plus RAB. For potential difference between point A and point J, it is directly proportional to the length of the wire from point A to point J. By dividing equation 1 with equation 2, we can find out that potential difference between point A and point J is equal to E1 times RAB divided by R3 plus RAB times length of the wire from point A to point J divided by length of the wire from point A to point B. For the second circuit, although there is a resistor, they will provide resistance here. Since the galvanometer shows no deflection, there is no current flow through the circuit here. The resistance will not disturb the potential difference between point S and point Y. Hence, the potential difference between point S and point Y is equal to the EMF of the second battery. As what I have said before that, potential difference between point A and point J is equal to the potential difference between point S and point Y at balance point. Hence, we can find out that EMF of the second battery is equal to the EMF of the first battery times the resistance of the wire between point A and point B divided by the R3 plus RAB times length of the wire from point A to point J divided by length of the wire from point A to point B. That's all from me. Thank you.
My name is David and now I'm going to do exercise number 6.
Mainly I'm going to do exercise 7.